So far this unit we've looked at Pythagorean Theorem, special right triangles, and using trig to solve for right triangles. So in the podcast today, that's what we're going to look at, those three methods for solving. So the first thing you should check for if it's a right triangle is if you have two sides. And if you do have two sides and you want the missing side, you can use Pythagorean Theorem to solve. So here, solving for the hypotenuse, let's label our sides here. The two legs are A and B. The longest side is C. So we have a squared plus b squared equals c squared, which is Pythagorean theorem. Let's plug in. So we have 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144 equals c squared. We got 169 when we combine like terms equals c squared. To get rid of a squared, use square root. And so here's c equals 13. And C should be the longest side, which if you check your answers here, it is. So there's how we can solve for the hypotenuse. To solve for a leg, again, we have two sides. We can use Pythagorean theorem. Let's label our sides again. So I'll call x A, 4 is B, the hypotenuse is C. Again, we have a squared plus b squared equals c squared. All right, here we don't know A, so I'll just call it x squared plus 4 squared equals c squared, which is 5. Okay, let's multiply out 4 squared is 16. 5 squared is 25. We want to get x squared by itself, so we're going to subtract 16 from each side. Oops. So we get x squared equals 9. And like the last problem, to get rid of a squared, use square root. So x equals 3. So solving for a leg, you have a little bit more algebra. You'll subtract and then take the square root. The second thing that we looked at this unit is special right triangles. The first one was half of a square, 45, 45, 90 triangles. And in half of a square, two sides are the same. So in the first triangle, we have one side is 5, the other side is 5, and the hypotenuse is 5 squared or 2. We can work backwards. If the hypotenuse is 12 squared root of 2, then the two sides must be 12. And if we have this side 9, which equals n squared root of 2, and we want n, the sides, we will divide by the square root of 2. And then we get n by itself. And so each of these sides of the 45, 45, 90 are 9 divided by square root of 2. In a 30, 60, 90 triangle, you either have n, 2n, or n squared of 3. So in the first triangle, this 20 is between the 30 and the 60. It's the longest side, so this is 2n. So 1n you would divide by 2. 20 divided by 2 is 10, and that's the smallest side between the 60 and the 90. So here a is 10. And then the medium side will be n squared of 3, so 10 squared of 3. In this triangle right here, we have n is between the 60 and the 90, the smallest side, so this is 3. We double it to get the longest side between the 30 and the 60, so this is 6. And then the last side will be 3 squared of 3. In the last triangle, 5 equals n squared of 3. So we're going to divide by square root of 3 to get n. That's our smallest side, 5 over square root of 3. You double it to get your hypotenuse between the 30 and the 60. And when you double a fraction, you only double the top. So this will be 10 over square root of 3. So we spent a few days looking at special right triangles, and the last thing that we looked at was trig, SOHCAHTOA. When it's not a special right triangle and you can't use Pythagorean theorem, let's solve for a side first. So first identify your angle that's not the 90. Label your sides. The hypotenuse is across from the 90, and then D is opposite the 34, so this is sine. So we have sine of 34, 35, equals opposite over hypotenuse, so D over 71. And then we're going to cross multiply and solve for a side. So I'll put this over 1. We have D equals 71 sine of 34. And we type that into our calculator, 71 sine of 34. And so that side was about 39.7. Okay, so for solving for sides, you identify your sides, pick your trig ratio, cross multiply, and solve. And let's look at using trig to solve for an angle. So again, circle your angle, that's not the 90. Identify your sides. We have the hypotenuse, we have the adjacent, so this is cosine. So cosine of E equals 46 over 50. And to solve for an angle, you take the inverse to get rid of the cosine. So E equals cosine inverse of 46 over 50. You type that in, cosine inverse, 46 out of 50. So that angle is about 23.1 degrees. I'll just round to the nearest degree, about 23 degrees. Number 6, show how you would solve for this angle. So in other words, you're solving for an angle. How do you get rid of the tangent? You take the tangent inverse. So x equals, again, if it's an angle, you just do the inverse. They already calculated this ratio right here. So you just type that in your calculator. Tangent inverse of 1.25. And that angle is about 51.3 degrees. Let's do a few word problems. Number 7, a sledding run is 300 yards long with a vertical drop of 27.6 yards. Oops. My workspace quit. Let's restart. Find the angle of depression of the run. Well, we know this whole unit is right triangle, so I'm going to start by drawing a right triangle. Okay, and filling in what I know. So we know that the sledding run is 300 yards long with a vertical drop, so the vertical drop is up and down of 27.6 yards. Find the angle of depression of the run. So the angle is from the ground up here. Let's identify our side. So if this is our angle, we have the opposite side, the hypotenuse, so this is sine. Sine of x equals opposite, 27.6 over 300. To solve for an angle, we take the inverse. So x equals sine inverse of 27.6 over 300. Put that in our calculator. And our angle is about 5.3 degrees. So I'll write it over here. X equals 5.3 degrees. Next word problem, a ski run has an angle of elevation of 24.4 degrees and a vertical drop of 1,000 feet. To the nearest foot, how long is the skiing run? Whoops, let's go back. All right, so let's draw a picture of this. All right, angle of elevation, again, our angle right here is from the ground up, 24.4 degrees. And a vertical drop of 1,100 feet. How long is the ski run to the nearest foot? All right, again, we have opposite, hypotenuse. We have sine, but this time we have the angle. Sine of 24.4 equals opposite over hypotenuse. Let's cross multiply and solve. 1100 equals x sine 24.4. To get rid of the sine of 24.4, we'll divide. And we have x equals, let's type that in, 1,100 divided by the sine of 24.4. All right, so that ski run is 2,662.76 feet long. So on the assignment today, you'll have these mixture of problems. You'll be practicing Pythagorean Theorem, special right triangles, and right triangle trig.